Okay, some of you have been wanting to do this, okay? But I said, wait till this week, all right? We can describe some of our does not exist limits, okay? I told you that we cannot evaluate a limit when it decreases or increases without bounds, correct? On your quiz, what did you have to write? Does not exist. Okay, some of you wanted to write, well, it keeps going to infinity, it keeps going to negative infinity. We can finally do that today, okay? For example, here I have a graph, y equals 3 over x minus 2. If we look at the right-hand limit, what is happening on the right-hand side of our asymptote? Okay, it's getting bigger and bigger and bigger and bigger as we approach the asymptote. The limit still technically does not exist, but we are going to describe it as reaching positive infinity. Okay? If we look at the right-hand side of 2, you see that our graph decreases forever and ever as we approach our asymptote. Okay? Yes, this limit doesn't exist, but we are going to describe it as going towards negative infinity. Okay? So when we have an asymptote, if we can describe the behavior of the graph as going towards negative infinity or positive infinity, we are going to write that instead of does not exist. It still means the limit technically really doesn't exist, but we're going to describe the behavior of the graph. Okay? Okay? So what's going to be important, all right, is that we know where our vertical asymptotes are. Where we have vertical asymptotes is where we're going to have this increasing or decreasing without bound. Yes?
And we can only write like positive or negative if it has on the certain side, correct?
Not necessarily. Now, if I asked you for the limit as x approaches 2, because right and left hand are not the same, and we'll go through an example. Okay? But the limit, for sure, doesn't even exist at 2 because our right and left hand limits are different. Okay? So the first thing we need to practice is making sure we know where our vertical asymptotes are. Okay? So here we go. Function h. Do we have any vertical asymptotes?
Yes.
Where at? 1. That's not a line.
X equals 1.
Thank you. Function j. How many vertical asymptotes do we have?
2. 1. 2. 1.
I hear 2. I hear 1.
2.
What should we do?
Simplify.
We should probably factor to see if we can simplify.
1.
X squared minus 4. What's happening at x equals 2?
Hole.
There's a hole. If we have a hole, the limit exists, right? Where's our vertical asymptote?
X equals negative 2.
Do we have a vertical asymptote at x
Yeah.
equals 2?
No.
No. If I asked you for the limit as x approaches 2, you better cancel out your factors and then you could evaluate it, correct? Okay. Function g. Does this have any asymptotes? I see question marks above some heads. What did you say, Eric? Okay, this function is the same as 1 over cosine x, isn't it?
So yes, I don't think they're asymptotes because it's just like a restricted meaning.
They are.
Okay, so it is.
Mhm.
Okay.
Remember when we drew these?
Yeah.
You would have to draw the period, and then you would have asymptotes here where cosine is 0, and then you drew in your u's. Remember that? Okay. So there's asymptotes anytime cosine is 0. When is the cosine of x equal to 0? Pi over 2 plus pi n. This is the same as we had to do yesterday, correct? Okay. Cool. So now we are going to use our knowledge of asymptotes to help us evaluate these limits. Now, first of all, anytime you evaluate a limit, the first thing you should always check to see if you can do is what? Direct substitution. If you cannot do direct substitution, then you need to look for, can I do one of our tricks? Can I cancel out any factors? Is it a special trig limit that we can evaluate? If none of those work, then we can fall back, okay, this is a vertical asymptote if we have a rational function. Okay, exhaust all of your options first. Okay? Okay, so here we go. Our first function, f of x, is -1 over x minus 1. And we are going to evaluate the limit as x approaches 1 for each side. Okay? Okay, so what is happening at x equals -1? So there's a vertical asymptote. Okay. We need to decide, in this case, on the left side, are we increasing without bound or are we decreasing without bound?
Increase.
Okay? So, how are we going to determine this?
Look at the parent function.
It's not always going to be a nice parent function. Okay? Tony.
Pick a point on either side of one of those.
Okay. Well, I'm not sure I'd say, well, we're only worried about the left side right now. Right?
Pick a point on the left side of x equals 1 and test that to see if it's above or below.
Okay. What do you think, Shannon?
Why you told us to plug in at least 2 poles? Are you gonna go in?
That's the list is where you need to pick one. Or if you already know then there's a horizontal asymptote of 1 equals 0. And so if you test a point on the left side and it's above that, it's going to be intrinsic.
Okay. What do you think?
I feel like you're not looking for the answers we're giving you. Very good.
Well, I mean, there's a few different ways to go about this.
I think
Okay?
testing different points. Zero, sign. Like 1 sign to see where it's taking.
Okay. Now, let's just say I plug in 1, right? We would get -1 over 0, right? But from the left side, would those numbers to the left of 1 make this right here negative or positive?
Negative.
Negative.
Which means that
So we're going to say it's positive infinity. Saves you from having to plug in 2 points. Okay? Or you can think about it, where's the horizontal asymptote? That's fine. Okay? The limit as x approaches 1 from the right side, if we evaluated it, it would be -1 over 0, but to the right of 1, this denominator would be positive. So we're going to describe it as negative infinity.
So you just pay attention to the signs.
And that's all we're going to show on the survey test.
What if I asked you the limit as x approaches 1 of this function?
You would find it from the left and the right.
Oh, look, we did.
And then you can just look at them and be like, oh, it doesn't exist.
Are the left and right the same?
No.
then we have to write does not exist. Now, if I give you this problem where the limit is approaching 1 and you just write does not exist, that's not sufficient anymore because you actually know how to evaluate the right and left hand sides of this asymptote. So you need to check to see if they're the same.
You can, like we were learning, we're just step.
All right, let's do this one. The limit as x approaches 1 from the left side of this guy. First of all, what's happening at x equals 1?
You get 0. It's the vertical asymptote.
We have a vertical asymptote, so we know that we're either going to increase or decrease without bound. So which one? All right. So here, we're going to have 1 over 0, but are we approaching 0 from the positive or negative side when we plug in to the left of 1?
It's squared.
It's squared, right?
So
So we're approaching 0 from the positive side, so it's going to be infinity.
wait.
Okay. The limit as x approaches 1 from the right side. Okay. Yes, we would have 1 over 0, but numbers to the right of 1 are going to make this denominator positive. So it is increasing without bound.
Its limit exists.
So now, if I were to ask you the limit as x approaches 1 of g of x, you would have to tell me it is
Infinity.
infinity. What does this graph look like? Oh,
It goes like this. Volcano. It's really tall. Like Mordor.
Some of the weird Waldo shirt on, maybe.
that is my child, A.
Yeah,
And I think he looks
I found
adorable.
him. I thought you would have had a picture of somebody else's.
Yeah.
Wait, you don't?
Okay, what was our function?
1 over quantity.
Quantity of x minus 1 squared.
Thank you.
1 divided by 1. Dang it.
Yeah.
When you have children, you'll want to put their pictures on your desktop background.
I'm sure.
What? She said, I said my dad does. It's embarrassing. But you said my dad doesn't because it embarrasses him.
All right, so look.
I was like, I would.
Here is our asymptote at x equals 1. You see that the right side and the left side are increasing without bound, just like we decided they
It's
would.
like Mordor.
Okay? That's not what I wanted at all.
It's like a wormhole.
All right, so questions on those 2 examples. Okay. Next one. First of all, does 0 make our denominator 0?
Yeah.
So what's happening there? There's a vertical asymptote because we cannot do anything algebraically to make the sign of x go away. So now we need to decide, is this, don't put it in your calculator, is this increasing or decreasing without bound? Okay? So, we're going to write our horrible 2 divided by 0. But are we approaching 0 from the positive or the negative? So to the right of 0, which means if we plug in like pi over 3 or pi over 6, okay? Does that make our sign of x positive or negative? Positive. So we are increasing without bound. This is the only time I will ever let you write a positive 0 or a negative 0.
I saw this one thing on the news channel and had.
Hold on, I'm going to answer Aaron's question, okay? All right. The sign of x Do you want to think of the graph or the unit circle, Aaron?
Probably the graph.
Okay, here's the graph of sine of x, correct? From the right side of 0, are we approaching 0 positively or negatively? From the right side, we have positive values,
Okay.
and so that's why I wrote the horrible positive 0, but that's how we describe it as a chili.
And so from the unit circle, it'd be because.
Because to the right of 0, we think of values like pi over 6. That's to the right of 0, correct? Mhm. So that's
So,
okay.
still infinity because you
Well, if this was from the left side,
yeah,
this would be negative
yeah,
infinity, wouldn't it? Mhm.
I got you.
Okay.
So the news thing I was watching,
Mhm.
it was showing all the highs and lows for the areas or whatever, and it was like the low for, I was like, it was like the giant, just stand in front of the green screen, you got all the numbers in the background. It's like, pause the screen, I was like, wait a second, and there's a number and it said -0, and I was like, no.
Yes, negative 0 and positive 0 aren't okay numbers, but we're going to use them to help us figure out if we're increasing or decreasing the
Why
values.
did it say negative 0?
Okay. All right. So here are just, you know, the combination of our limits. Okay, we've talked about these properties with our limits existing. Okay, but if f has a limit of infinity and g has a limit that exists, when I add them or subtract them, the limit's going to be infinity. If I multiply them, the limit's going to be infinity. If this limit's positive. If this limit's negative, we would say negative infinity. That would make sense, right? And if we divide them, g over f, we get 0. Why does that make sense?
You're dividing
Infinity.
all these numbers underneath it, which are
Okay?
It
If
approaches-
if f has a limit that approaches infinity, our numbers keep getting bigger and bigger and bigger and bigger and bigger and bigger and bigger. So if we're dividing by a super big number, we're approaching 0. Okay? The bigger the denominator gets, the closer our quotient becomes 0.
Good job.
So, like,
X
if
over
it's-
G of X, infinity, then.
Yes. Is that your question,
I think
Tony?
I was gonna ask what would happen if it was F over G.
If it was f over g, then it would be infinity. Yeah, because you could think of multiplying by the reciprocal of L, and it would be kind of the same as here. So negative infinity or positive infinity, depending on what value L has.
What if it's f of x over g of x and the limit of g of x is negative infinity?
Well, the g of x is L, so that's not that's
F of
not a
x
part of
is
any of these
negative.
properties.
Okay.
Okay. If it's infinity over infinity, that's a whole new ballgame that we're not gonna talk about.
Then it equals one.
No. No. Yes.
It equals 88.
So if f of x is negative infinity, all these are switched.
Yeah. There, right there.
Hey.
Okay. Here's a graph.
Ooh.
Whoa.
Never seen one.
See one.
Think about it. Caleb, if I asked you this, what would you tell me? What do you think it should be?
tell you.
Couldn't tell you. Okay, what was your thought process?
So I find what's at -1 on both graphs. Both, from the part to the left side,
Okay, so for f of x, what is it?
-1,
-1. For g of x, what is it?
0.
0. Okay, well, we know that that's going to give us a positive or a negative infinity, right? So we need to decide which one. So we're approaching 0 with what kind of values over here?
From the left side, it's very simple values. Things are larger.
Still negative values.
The values are negative, correct?
See. Gotcha.
Okay, so what do we have?
Now, how would we
Graph it? And we're not going to graph it. Okay? The limit as x approaches -1 from the right side of the quotient, f of x divided by g of x. Think about it. We're going from the right side now. From the right side, our limit for f of x is -1. For g of x,
Positive 0.
0, but we're coming from positive x values, or y values. Does the limit as x approaches -1 exist? No, because right and left hand limits would not match.
No,
Okay? So, the intermediate value theorem, you're going to have from page 77, numbers 83 and 84. And then for your infinite limits, page 85, you're going to do 1 through 8 and 13 to 53 odd.